So let's do some examples with derivatives of exponential functions. It says find the derivative of the following functions. A, f of x equals 3 to the x. So the derivative of that would be equal to 3 times the derivative of e to the x. Well, the derivative of e to the x is just e to the x, so that's 3e to the x. Very, very simple problem. With exponentials, I like saying copy, paste. Copy, paste is what I like to say, okay? So next one, f of x equals x squared plus e to the x. Well, the derivative of that would be equal to the derivative of x squared, which we determined as 2x to the 1 using the power rule, plus the derivative of e to the x, which is just e to the x. So I'm getting 2x plus e to the x as my final answer. Okay, let's move on. It says f of x equals sine x minus e to the x. Here, to find the derivative, we just find the derivative of each part. The derivative of sine we know is cosine of x. So that's the derivative of the first part, minus the derivative of e to the x. Well, the answer there is e to the x. So I'm getting cosine x minus e to the x. Cosine x minus e to the x. Okay, so let's continue on looking at the next part, talking about rates of change. So what does it say? It says you have seen how the derivative is used to determine slope. The derivative can also be used to determine rate of change of one variable with respect to the other. Applications involving rates of change, sometimes referred to as instantaneous rate of change, really important there, instantaneous rate of change, occur at a wide variety of fields. A few examples are population growth rates, production rates, water flow rates, velocity, acceleration. And it says a common use for rate of change is described the motion of an object moving in a straight line. In such problems, it's customary to use either a horizontal or vertical line with a designated origin to represent the line of motion. In such lines, movement to the right or upward is considered to be positive direction, and movement to the left or downward is considered to be the negative direction. The function s that gives the position relative to the origin of an object of a function of a time t is called the position function. Okay, so what did they just say right there? When we're considering movement in essentially a two-dimensional manner. So what we're considering here is, imagine if you had a ball in your hand and you went to the top of the building and you dropped it, and all we care about is the height. We only care about one direction, up and down, or left and right, okay? We do not consider both directions. I know if you drop a ball, the wind's going to take it a little bit, right? And it's not going to land directly below where it was dropped. So we have to consider this as happening in a vacuum. There's no air resistance and there's no movement left or right. All we care about is movement up and down. So that is called the position function, looking at just the height of that object. So this gives us average rate of change. So what is average rate of change? Average rate of change to us is the secant line. The average rate of change is just the slope between 2 points. You have point 1, point 2. The average rate of change, if we called this point A, f of A, and we called this B, f of B, would just be the slope between those two lines. So the average rate of change is just the slope of the secant line. Average rate of change is just the slope of the secant line. Okay, very easy to find the average rate of change.